Let's begin this lesson with tangent and cotangent. We're going to look at y equals tangent of x. Let's remember that tangent is y over x or sine over cosine. So quadrantals, y over x, that would clearly be a 0 over 1, which would make that 0. Pi over 2, that would be 1 over 0, which would be undefined. So we'll just put UND for that one. Pi itself, pi would be 0 over -1. That's fine. That's acceptable. That would just be 0. 3 pi over 2. Well, 3 pi over 2 is going to be, let's see, -1 over 0. We can't have that, so that's undefined. And then lastly, we have 2 pi. And 2 pi is the same as 0 pi, which would just be 0. Let's get a rough sketch of what this graph will look like. Okay, so just looking at the quadrantals right now, we got 0, and then we've got pi 0, and then we have 2 pi 0. And remember, this function will not be defined at pi over 2 or 3 pi over 2, so we are going to have asymptotes there. So let's get the ruler out to denote that. Okay, so we're going to have a much different looking graph here than what we were dealing with last lesson. Let's look at the pi over 6 family. Okay, in quadrant 1, we can see that's going to be pi, it's going to be y over x. This will be 1 over root 3. So that's, of course, going to be root 3 over 3 after we rationalize the denominator. That's going to be a negative in quadrant 2 because tangent is negative in quadrant 2. Same absolute value. It's positive in quadrant 3, so that's root 3 over 3. And in quadrant 4, it's going to be negative again, so that'll be a negative root 3 over 3. Now let's graph these, but before we do, let's figure out what the decimal value is here. That'll be a little easier. That's root 3 divided by 3. A little more than a half, so about 0.6. About 0.6. So on this line, we'll start with pi over 6, which will be about a third of the way over. And of course, it's not done nicely like that. But it should be a little more than a half, so probably right about here. So 5 pi over 6. Let's see, so that would be, let's see, that would 5 pi over 6 would be right before pi, and that would be negative, so probably like right here, and then go down 0.6, so right about there. 7 pi over 6 will be a little bit more than 1 there, so right there is a pretty good estimate. So that'll be there. And then 11 pi over 6 will be back to the negatives again. That'll be a little less than 2, so probably right about there. All right, let's check out the pi over 4 reference angles. So remember, once again, tan is y over x. And in the case of pi over 4, you're cutting the triangle into a 45, 45, 90. And that's, of course, going to give you lengths or legs that are the same length. So you're going to have an absolute value of 1 for each of them. But in quadrant 1, it'll be positive. In quadrant 2, it'll be negative. Quadrant 3, positive. And quadrant 4, negative. Graphing pi over 4 will be a little easier. Pi over 4 will be right in between these two, so that would put that at 1. And then let's not forget 3 pi over 4, so that's going to be in between pi halves and pi, so that would be 3 pi over 4, -1, so that would be down here. 1. And then 5 pi over 4, that's going to be in between, let's see, a little bit closer here, so 5 pi over 4 would be right about here. And 7 pi over 4 would be -1. 7 pi over 4 would be probably right about here. And there we go. So we get kind of a strange looking shape here. We've got one more set of reference angles to go. Let's go do them. Okay, pi over 3. So that's going to be y over x, which is just going to be root 3. That's positive here. And all the other ones will follow suit. They'll just be negative in quadrants 2 and 4. So that'll be root 3. That'll be negative root 3. So now we will graph these, but we're going to use the calculator so I know exactly where to go with this. So the square root of 3 is going to be 1.73. Pi over 3 would be pretty close to pi over 2, and 1.73, it's going to be probably like right over here somewhere. Alright, and then we got 2 pi over 3, and 2 pi over 3 will be a little greater than 1/2 pi, and that's going to be negative 1.73, so that'll probably be, let's see, that's 1.5, so right about here. And then 4 pi over 3 will be root 3 again, so that's going to be pretty close. Yeah, let's say right about here. And then lastly, we've got 5 pi over 3. That'll be negative root 3, which is maybe somewhere around here. Okay. So I'm going to take my black marker here, and what appears to be going on here is we've got a line that kind of goes like this, right? Goes up, and then goes up. Kind of looks a little bit like that. I'm sure Desmos can do a better job than I just did, because I don't really have a tool that does that nicely for me. So let's actually look at what this graph looks like when you punch it into a graphing calculator. Okay, there it is. So I paused because I wanted to draw in the vertical asymptotes that we're seeing each interval here. So this is y equals 10 of x, and it looks like it alternates between being in the positive, being in the negative quadrant, and then of course the times hitting the x-axis perfectly. If we just look at the very first cycle, so just the first cycle, right, just going around here, and we analyze this, we can kind of see what's happening here. Alright, so this is the first cycle, and we can see this is representative of quadrant 1, and you can see it's positive. Okay, and then it goes, and then it's undefined once it gets to pi over 2, and then it continues on to quadrant 2 where it's negative. Then quadrant 3 it becomes positive again, and finally quadrant 4 it becomes negative again, and this cycle would just repeat. We notice that the asymptotes are located, what's the best way to say this? It's not all multiples of pi over 2, because obviously pi is a multiple of 2, and that's defined at pi, but it's undefined at pi over 2, and from there you just add pi, and then on the other side, the same thing, it's undefined at pi equals or negative pi over 2, and then you just add pi, and it's going to be undefined at each of those intervals. So let's look at some of the key features here of the graph of y equals tan x. Oh, I forgot to put an x in here. So the period, well, just look at where I drew those vertical asymptotes. That's a period long, so that would be pi. The domain, well, the domain's everything, but it excludes some things, so it's a little trickier. I'm going to write excludes pi over 2, and that would be plus pi after that, so every pi after that. So let's say k times pi, and that also works in the negative quadrant as well, or the negative side of the line. So I guess that would be excludes, oh, I forgot to spell excludes wrong. Negative pi over 2 minus k times pi. Alright, what about the range? Well, the range, it goes on forever. So it's going to be negative infinity to positive infinity. Other features of the graph, well, it has vertical asymptotes at intervals, at intervals of pi plus k times pi and negative minus k times pi. It passes through the origin. That's another thing. Okay, now let's take a look at cotangent. There is cotangent. You can see it looks very similar to tangent. Definitely distinct from the graphs we saw yesterday, which was kind of like the rolling hills, rolling for all of eternity. These two definitely are distinctive, so when you see these, you should be able to say, oh yeah, that's either tangent or cotangent, and then you might have to just look a little closer. Obviously, the quadrants and positive and negative signs are not going to change. So you can see positive in quadrant 1 for cotangent, negative in 2, just like the other one. Quadrant 3 was positive, quadrant 4 was negative. So that hasn't changed. What has changed is that in tangent, the values rise from left to right, and with cotangent, they fall from left to right. So I'm gonna just note that here, rise from left to right, because that's a big distinction that we can notice here. All right, so what about the domain and the range? Well, you may have noticed that the vertical asymptotes have shifted. They were at pi over 2, 3 pi over 2. Now they're at 0 pi, pi, 2 pi. So the domain still has everything. Oh, I forgot about period. Period is still the same. In fact, it's easier to see here that the period is pi. The domain is going to include every number except it's going to exclude pi plus k times pi, with k being any factor, multiple number by pi. The range, again, that's going to keep going on multiple times, infinite number of times. The other features, well, vertical asymptotes are at pi, 2 pi, 4 pi, ... Actually, they're at pi, 2 pi, 3 pi, though. Why did I skip 3 pi, 4 pi, and now I can put the little ellipses. Okay. This graph does not pass through the origin. So that's how we could distinguish this. Does not pass through origin. And the values fall from left to right. Within the restricted domains, though. Because if you're just looking at the values within the domain, they fall from left to right. But obviously, once you go into a new cycle, the values go back up again. Okay, so that is tangent and cotangent.